We are going to find the perimeter of MNPQ given that this angle is 120 and it says that QP is 18. So I don't think this 18 belongs here. It belongs here on QP. So I'm just going to hide this because we don't want to see it. That's not what I want. I need to choose this. There we go. I want to fill this with white. And I want the edges to be white. Nope, didn't work. Anyway, this is the dimension that's 18. Now, if this is an isosceles trapezoid, it means that these sides are congruent. It means that these base angles are congruent. If these are bisectors, that makes well, let's do it this way. In a trapezoid, oh, I'm thinking of the wrong thing. Well, we know that these are congruent. And so we also know that this is 120. We have side angle side. This triangle is congruent to this triangle. And this is also 120. Let's do it that way. This is a quadrilateral, so it's got 360 degrees altogether. And we're using up 240 here. That leaves 120, and these have to each be congruent. So that puts 60 here, which makes each of these small angles here 30. This one is 30. And this one is 60. So this is 30. And this is 30. Now, we know all triangles have 180 degrees. So if this is 30 and this is 120, that's 150. That leaves us 30 here. This is actually an isosceles triangle, even though it doesn't look like it. So what that means is that TN right here with two green marks is congruent to NP right here. Okay, we're looking at this triangle from T to P to N. So we're looking at this triangle. It's isosceles. And so I think I'm going to erase these for a minute. That's not what I want to erase. Oh, I got to move it. Because they aren't going to help me. Having the two green marks here, because this is an isosceles triangle, will help me. And so likewise, I have a green triangle over here that is also an isosceles triangle because both of the base angles are 30 degrees, which means that this side is congruent to this side. So now we would know the perimeter because the perimeter is 18 plus this side, and they are the same, plus this side, which is the same, plus this side, which is the same. So we can start to write our perimeter. It's going to be 18, that's QP, plus 4, pick on one of these sides, or we could call them each x, plus 4x. if that's the length of this side. So we just need to find the length of this side. Now, I believe that the trick here is to see, how did I do it? First of all, let's use this 30, 60, 90 triangle for just a minute, okay? So I'm going to put a blue line right here. This is 60. This is a 30, 60, 90 special right triangle. This side is 9. This side is 9. So this is the long side. So the short side is 9 divided by the square root of 3. And the hypotenuse is twice that. It's 18 over the square root of 3, but we don't really need this. It's not going to help us. What is going to help us is to now, let's redraw this, just one of these sides for a minute, where this is going to be T, and this is going to be N, and this, whoops, I need this. And this, I just need it bigger so we can see what we're doing. This is going to be P. Right here. Okay, so I'm just looking right here. If instead of doing these bisectors, if instead I would drop a vertical right here, okay, and just look at this triangle. Notice if I go from N to the base here, it's going to be the same height as from T to the base. So I know that this is 9 over the square root of 3. Okay. I would have to go all the way here from T over to P to get that this whole thing is 9, right? That's this dimension right here. But that's not what I'm interested in, because P here is a 60-degree angle, right? It's this 30 plus this 30, and this is 90, and so this is 30. So this is the short side of a 30, 60, 90, and the hypotenuse is twice its length, which is 18 over the square root of 3. And if you have to rationalize that. But anyway, this length is x, right? It's this. It's n to p. And the perimeter is 4 times these x's plus 18. So this is 18 over the square root of 3. And if your teacher wants you to rationalize, please feel free to rationalize, but there's the answer. That is the perimeter of that trapezoid.